So for changing a fraction to a percent, if you have something that is 3/10, a decimal would be 0.3. And then to change a decimal to a percent, we move 1, 2 over, and it would be 30%. If it was over 100, then we would do 0.03. So this right here could move over and 0.30, sorry. And then we move over 1, 2, it's 30%. For this one, we have 3/4. You take the denominator, which would go here, and then going by the numerator right here. So the denominator is 4 and the numerator is 3. And then you say, how many times does 4 go into 3? It goes in 0 times. So you put a decimal right above the 3 and you add a 0. 4 goes into 37 times. 7 times 4 is 28. 30 minus 28 is 2. And then you add another 0, bring it down. 4 goes into 25 times. 0.75. And then if you were turning that into a percent, you would move it over. So we have 0.75. We'd move it over 2, 1, 2, and it would be 75%. Okay, next thing we're going to do is you have something called prime numbers and composite numbers. So a prime number is a number that only has 1 and itself as factors that will divide into it. So the number 2 and the things that can divide into 2 are 1 and 2. That's a prime number because we only have 2 factors, 1 and itself. 3 is a prime number, 1 and 3, nothing else divides evenly into it. And then let's look at 4. So 4, we have 1 divides into it and 4. It always has 1 in itself, but 4 also has 2. So this one is called a composite number. It is more than 2 numbers will go into that number dividing in. Okay, let's look at 5 and see if it belongs in the prime or the composite. 1 and 5 are the only things that go into it. So this is a prime number. Let's look at 6. 1 goes into it, 2 goes into it, 3 goes into it, and 6. So it is a composite. All right, now in 4th grade, what they might have you do is something called a prime factorization tree. And what we're going to do is they're going to say do a prime factorization tree. And what this means is you're going to take 2 things that can divide into 16. So you can pick any 2 numbers except for 1 and 16, because if you did 1 and 16, you wouldn't make the 16 go lower. So what is another 2 numbers that go into 16? So I'm just going to pick 2 and 8. I could also pick 4 and 4, but I'm just going to pick 2 and 8, and it doesn't matter what you choose. And then once it's a prime number, like we know from up here, 2 is a prime number, I'm going to circle it. So I circled my 2, and then what goes into this number right here? 8. So I'm going to make another branch on my tree. And then what are 2 numbers that go into 8? 2 and 4. So I'm going to circle my prime number. And then this has another branch because I can do 2 and 2. 2 times 2 is 4. Now I'm going to circle that. Now my last step is writing all of these out. They're not going to always be the same number, but for this one it is. And I have it 2 times 2 times 2 times 2. If I did something like 49, what are two numbers that go into 49? 7 and 7. Now we look at this and we say, can I make a branch from 7? No, because 7 only has 1 and 7. So I'm going to circle this number and I'm going to circle this, and then I just write 7 times 7. And I'll do one more for an example, 81. So 81 has 9 and 9 as my number, and then 9, I can do a branch off of both of my 9s because 3 times 3 is 9. So then I circle this because 3 cannot go any lower. The only factors that go into 3 are 1 and 3.